In question number 11, we see that there's only a horizontal transformation occurring here, and we want to do the compression expansion first before we do the horizontal shift. So in this case here, we can see that it has original width of 24 and has a new width of 12. So in terms of the change in x, okay, we know that the new x first has a horizontal compression by 1/2. So I'm going to take those x coordinates and I'm going to divide it by 2. Now we have to be now aware of the horizontal shift. So what ends up happening is that vertex would end up in the same place, but now it's been shifted 6 to the left. Okay, so then that's going to be our translation there. We're going to do -6. Okay, so again, this is not what we're going to put in our function notation. Okay, that's the actual transformation. That's what actually happened. The notation, we're going to undo all of this. So we're going to add 6. We're going to times by 2. We end up in factored form. So this is going to be what I put into the notation. And the notation in factored form shows me that I did the compression first, shift last. Okay? And that's generally what we want to end up doing. So if you know the factored notation, then we don't necessarily need to do this, because the way it's described, that way we transformed it, was compression first, shift last. So writing this in function notation, we're going to have f of, and we're just going to plug that in, 2x plus 6, all in brackets. And again, the factored form indicates that the way we transformed this was shift last. Okay, and if we take a look at this expression here, which actually does the transformation, we can see that, yeah, the compression happened first, shift last.